Welcome everybody to Trigonometry Sine and Cosine Law Lesson 2. So now we're going to move into some new stuff. We did a review of right angle triangle trigonometry from grade 10, and hopefully that went really well. So now we're going to move on to some new stuff. We're looking at trigonometry in acute and obtuse angled triangles, so non-right angle triangles. Going to skip over the first page. I think it's really cool and awesome, but with respect to the time, I want to just jump in and give you the just basically the sine law. I don't want to make it fancy. I don't want to make it overloaded. I just want to talk about what the sine law is. So we are going to learn about the sine law and the cosine law. So let's get started. We start with a new notation. So I want to talk about how we're going to label our triangles in a really nice and convenient way. So if we have this triangle here, ACB or ABC, you can see that it's not a right angle triangle. There's no angle that's a right angle, and that's okay. When we label this, we know that this is angle A, represented by that capital A there, and the side across from it, we're going to label little a. So capital A is the angle, and opposite of it is side A. And we're going to do the same thing. So angle B is this angle here, and the side opposite of it is little b. And then last but not least, we have angle C up here, and the side across from it is side C. So we use lowercase letters for the side lengths, and we use capital letters for the angles. And you can see here that now that we know this, the sine law has a little bit of context. So it does look big. There's 3 parts to it. When you use it mathematically, you only need to use 2 parts of it. Or you can flip everything. So you see here we have A divided by sine of A is equal to B divided by sine of B is equal to C divided by sine of C. Or we can put those sine functions on top of the fraction, which it gives you the exact same formula, just flipped. So sine of A divided by side length A is equal to sine of B divided by side length B is equal to sine of C divided by side length C. So when we're using this mathematically, depending on what information you know, you only have to use, for example, A sine of A is equal to B sine of B. And you're going to know 3 pieces of information, and you're going to solve for the 4th one. Or maybe you know angle A, and you know side length A, and you know angle C, and you're looking for side length C. So now you can get rid of that middleman there, because we know if they all equal each other, then this is also true. So let's do an example, and you'll start to see what I mean. I'm not going to do the proof. As long as you believe that this equation works, then we're totally good. If you, for some reason, are sitting at your desk and you're thinking, something doesn't seem right about this, I don't agree, come see me. We'll walk through the proof, and I can prove to you that this equation works. But for now, in this class, as long as you can use the sine law, then we're good to go. So we'll skip to the top of page 225. So it says here, to use the sine law, we need to know 3 pieces of information. And if we look at our formula, maybe I'll put it over here. A sine of A is equal to B sine of B, which is equal to C sine of C. In order to use this formula appropriately, or to use it effectively, we need to know an entire part of this. And what I mean by that is we need to know an angle A and a side length A, or we need to know angle B, side length B, or we need to know side length C, angle C. So we need to know an entire one of these in order to use this formula. So let's have a look at our triangle here. We have triangle ABC. It says use the sine law to calculate the length of BC and compare your answers to the SOHCAHTOA method. We didn't do the first page of this, so we won't have an answer to compare to, but I can use this to show you how to use the sine law, which is what we're here for today. So we want to label our triangle. If this is angle A, then we know that this is side A, the one across from it, right? If this is angle C, then we know this is side little c. And if this is angle B, then we know that this is side little b. So what information do we know? We know angle A. We know angle C. Hang on, I was wanting to use a different side here, different color. We know angle C and we know side length C. We don't know anything about B, so we won't use it. And here the question asks us to find length BC, which is technically side little a, right? It's this side right here. So we know both angle C and side length C. So we know both of those. And we know angle A, but we're looking for side length A. So what we can do is we can use those two pieces of that formula. A divided by sine of A is equal to C divided by sine of C. We don't need to worry about the B part of it. We only need to know or use two of those fractions. Excuse me. Let's fill out the information we know. We don't know side A, but we know angle A is 75. We know side C is 12.5, and we know angle C is 35. So what we can do is we want to get A by itself. We can multiply both sides by sine 75. They cancel out on this side, and what we're left with is A is equal to 12.5 multiplied by sine of 75, all divided by the sine of 35. Be careful here, that's a multiply. And now we can type that into our calculator, 12.5 multiplied by sine of 75. And then once we get an answer, divide by sine of 35, and we get 21.05. So that means that, centimeters, sorry, don't forget your units. That means side A is 21.05 centimeters. Hopefully that made sense. So it says here, use the sine law in the triangle shown to determine the measure of angle ACB to the nearest degree. So angle ACB is the angle formed when you move from point A to point C to point B. So it's a weird notation, I know, but if you come from A and then you go to C and then you carry on to B, you can see that the angle formed is actually just angle C. Does that make sense? So what this means technically is angle C. So what do we know? Well, we know angle A and side A, because we know that this is going to be little a, this will be little c, and this will be little b. So we know angle A and side A. That's good. We need to know one of those fractions. They want us to find C, angle C, but we don't know side C. So it actually doesn't work. We can't calculate anything to do with the C values just yet. So we know angle A and side A, and we know side B. So what we can do is we can find angle B, which we'll do right now. So we know that our formula, I'm going to use the flipped version of our formula, and I'll show you why. So we have, and by flipped version, I mean I'm going to put the sine values on the top. Sine of A over A is equal to sine of B over B. And actually, it's better to flip-flop it, so wait before you write anything down. I always put my unknown first, so this is a good strategy that I totally forgot to mention. What I'm trying to solve for is angle B. So I'm going to start by putting the value where angle B is in the top of the first fraction. And now I know that I can make that equal to sine of A over A. You can put these in any order, right? They're equal to each other. And this is just going to save a bit of algebra, which is really nice. So if we put our unknown in the first value in the top of the first fraction, we're going to save a ton of algebra. So now we can fill in what we know. We don't know angle B just yet, but we know side B is 6, and we know angle A is 110, and side A is 9.4. So now we want to get sine of B by itself. We can multiply both sides by 6, and what we're left with is sine of B is equal to sine of 110 multiplied by 6, or if you want, you could put the 6 first. 6 multiplied by sine of 10, all divided by 9.4. And in order to solve for B, we want to get a value for this, right? What if we type 6 multiplied by sine of 110, all divided by 9.4, we get sine of B, sine of capital B is equal to 0.5998. And that goes on, but I'll just leave it there. Now we have a value, so what we can do to solve for B is we can say capital B, or angle B, is equal to the inverse sine of 0.5998. Right, when we're solving for an angle, we have to use our inverse trig functions. So now we get B, I'm kind of all over the page here, I apologize. B is equal to 37 degrees. So this angle up here is 37 degrees. Well, if they were wanting us to solve for angle C, how did angle B help us? Hopefully, some of you remember that all the angles in a triangle need to add up to what? Correct, 180. All the angles in a triangle add up to 180 degrees. So we know two of the angles, we can find the third angle. So we can say 180 minus angle A, which is 110, minus angle B, which is 37, should equal angle C, which is 33 degrees. So that means angle ACB is equal to 33 degrees. That was a bit of a process, but we used the sine function, or the sine law, to find angle B, and then we used angle A and angle B to find angle C. So it works. Yay. All right, here we go. One last problem. Trying to keep these videos short, but only do so much. It says here, a surveyor measures a baseline PQ to be 440 meters long. So the first thing I'm going to do is label that. 440. He takes measurements of a landmark R from P and Q and finds that QPR is 46 degrees. So this is the angle when you've moved from Q to P to R. So Q to P to R forms this angle, right? So that's 46 degrees. And PQR is 75. PQR is 75. So that'll be 75 right there. Calculate the perimeter of the triangle. So the perimeter means we have to calculate the distance around the outside. So that means we need to find side length little q and side length little p. And this is side length r right here. So in order to do this, we need angle r as well, which we can find because we know that all of the angles in a triangle should equal 180. So angle PRQ will equal 180 minus 46 minus 75. So we know that that angle at the top is 59 degrees. And now we can use some sine law to figure this out. We know side r and we know angle r, so this allows us to use the sine law. We need to have a pair like that, we have as knowns, in order to use this law. So let's start by solving for side length q. So we're solving for little q, or side length q, so I'm going to start by writing my formula with little q in the top left. And now I'm going to make that equal to r sine r, because those are our knowns. We know those values. Now we can plug in what we know. Little q divided by sine of 75 is equal to, little r is 440 over sine of 59. We can multiply both sides by sine of 75. So that those cancel out on that side. And we have little q is equal to 440 multiplied by sine of 75 all over sine of 59. And when we type that in our calculator, we get little q to be 495.83 meters. Now we can do the same thing to solve for length p. So again, I'm going to put small p in the top left, and I'm going to use, even though I calculated q and now I have the pair angle q, side q, I'm going to use angle r and side r. I'm just more confident in those values, and they gave us 440. So, oops, little r sine of capital R. So now we can plug those values in. P over sine of 46 is equal to 440 over sine of 59. Multiply both sides by sine 46. Cancels out on this side, and what we're left with is P is equal to 440 multiplied by sine of 46, all divided by sine of 59. Type that into our calculator, and we get the side length of P to be 369.25 meters. Don't be fooled, we're not done yet because we have to find the perimeter. So we want to add them all together. So perimeter is going to equal, maybe I should write perimeter because we have angle P and little p. Perimeter is going to equal 440 plus 495.83 plus 369.25. So our perimeter should add up to 1,305 meters. It says to the nearest meter, so I rounded that. And we're done. Yay! Lesson 2 done. We only have one more lesson to trig, and then we're done trig forever for this course. Haha. See you guys later.